If you were to point the Hubble Space Telescope at a specific, seemingly empty patch of the Virgo Cluster and leave the shutter open for days, the resulting image would show you exactly nothing. A black, hollow void. No stars, no nebulae, no distant flickering of ancient quasars. For over a century, we have operated under the assumption that where there is mass, there is light. We believed that galaxies were, by definition, collections of stars. But in the last few years, our most advanced instruments have begun to whisper a terrifying correction to that assumption. You are looking at a structure 3 times the size of the Milky Way. It has the mass of 1 billion suns. It possesses the gravitational fury to shred neighboring worlds. But if you looked at it for 1,000 years, you would see nothing. This is the era of the Dark Galaxy, the discovery of massive, gravitationally bound phantoms that haunt the cosmic web, invisible predators that never ignited, never glowed, and never intended to be found. For as long as humans have looked at the sky, we have been victims of a profound optical illusion. We have mistaken the foam on the waves for the ocean itself. When we look at the iconic images of the Andromeda Galaxy or the pillars of creation, we are seeing the 1% of the universe that happens to be loud enough to emit photons. We see the fire, but we ignore the smoke. Modern cosmology tells us that for every gram of visible matter, the carbon in your bones, the gold in your ring, the hydrogen in the sun, there are 5 grams of something else. Something dark, something that does not interact with light. For decades, we believed this dark matter was merely a cosmic glue, a passive scaffolding that held the real galaxies together. We were wrong. We are now finding that the scaffolding can exist without the building. We are finding galaxies that are pure shadow. The first time we truly heard one of these phantoms, it sent a shockwave through the astrophysical community. In 2005, a team of astronomers using the Lovell Radio Telescope began tracking a massive cloud of neutral hydrogen gas in the Virgo Cluster, roughly 50 million light-years away. They named it Virgo He 21. On paper, it looked like a galaxy. It was massive, spanning tens of thousands of light-years. It was rotating, a clear sign of a gravitationally bound system. But when they pointed every optical telescope on Earth at its coordinates, they found nothing. No stars, not even a faint dwarf population. It was a galaxy-shaped ghost that had never triggered the process of star formation. It was a failed galaxy, a massive reservoir of gas trapped in a dark matter halo that, for reasons we are only now beginning to understand, remained eternally dark. This was not a mere curiosity. It was a crisis. If Virgo He 21 existed, it meant the universe was filled with invisible giants. To find them, we had to stop looking for light and start listening for the hum of the abyss. This is where radio astronomy transforms from a branch of science into a form of cosmic sonar. Using facilities like the 500-meter Aperture Spherical Telescope, or FAST in China, and the Meerkat Array in South Africa, we are no longer looking through a lens. We are pinging the darkness. We are looking for the 21-centimeter line, the specific radio frequency emitted by neutral hydrogen. When we map the universe in this frequency, the voids between the stars begin to glow with a cold, ghostly light. We are discovering that the empty space between the galaxies is actually a crowded highway of dark matter halos and starless gas clouds. But the existence of these dark galaxies introduces a sense of cosmic paranoia. To understand why, we have to look at the missing satellite problem. According to the Lambda Cold Dark Matter model, our current gold standard for how the universe evolved, the Milky Way should not be alone. Our galaxy is a massive gravitational anchor, and the models predict that we should be surrounded by hundreds, if not thousands, of smaller satellite galaxies. Yet, when we look around, we only see about 50. For years, skeptics used this discrepancy to argue that our understanding of dark matter was fundamentally flawed. They claimed the missing galaxies didn't exist. But the dark galaxy theory offers a much more unsettling explanation. The galaxies are there. They are in the room with us right now. We just can't see them because they are dark. Imagine the Milky Way as a brightly lit campfire in the middle of a pitch-black forest. We can see the people sitting around the fire, the large and small Magellanic Clouds, the Sagittarius Dwarf. But just beyond the reach of the firelight, the forest is teeming. Hundreds of dark, invisible predators are circling us, their presence known only by the way they subtly tug on the edges of our galactic disk. We are being stalked by a hidden population of sub-galactic halos that never formed stars, either because they were too small to hold on to their gas or because the intense radiation of the early universe, the cosmic dawn, blew their star-forming material away before it could collapse. We are living in a ghost hive. But this discovery has ignited a fierce cosmic detective story as astronomers struggle to distinguish true phantoms from the wreckage of ancient violence. Not every shadow in the void is a primordial galaxy. In the mid-2020s, a new tension gripped the field as researchers realized they might be looking at tidal debris, the shredded, starless entrails ripped out during high-speed galactic collisions. When two massive galaxies dance too close to one another, the gravitational tides can rip away vast plumes of gas, flinging them into the intergalactic void. These plumes can be massive, they can rotate, and they can appear dark. They are not ghosts, they are cosmic garbage. Take the case of FAST J0139 plus 4,328. When it was first discovered, it was hailed as the definitive dark galaxy, a massive rotating disk of gas with no visible stars. But deeper, more sensitive optical surveys soon revealed an incredibly faint, sparse population of stars hidden within the gas. It wasn't a dark galaxy. It was just a low-surface brightness galaxy, a structure so thin and diffuse that it barely registered on our sensors. This led to a great debunking period. One by one, the phantoms were being unmasked. The missing satellite problem seemed like it might be solved not by invisible galaxies, but by a simple failure to see the faint ones. But just as the skeptics were ready to close the case, the universe provided an anomaly that could not be explained away. Enter Dragonfly 44. Located in the Coma Cluster, Dragonfly 44 is an ultra-diffuse galaxy that defies every rule of galactic architecture. It is as large as the Milky Way, but it has 100 times fewer stars. When astronomers measured the velocity of the few stars it does have, they realized something impossible. The stars were moving far too fast. The only way those stars could stay bound to the galaxy was if Dragonfly 44 was 99.99% dark matter. If you were to stand on a planet orbiting one of the few stars in Dragonfly 44, the night sky would be a terrifying, absolute black. There would be no Milky Way band, no neighboring stars, just a handful of distant, lonely sparks in a sea of nothingness. And yet, you would be standing in the middle of a gravitational titan. Then came the Noob, or AGC 229,385. Discovered using data from the Green Bank Telescope and the GTC, the Noob is a massive, faint smudge that is 10 times fainter than other galaxies of its type. It is so diffuse, so spread out, that it shouldn't exist according to our standard models. It is too big, too stable, and too dark to be tidal debris. It is a primordial structure that has survived for billions of years without forming a significant number of stars. The noob is the smoking gun. It proves that there are structures in this universe that are fundamentally different from the galaxies we know. They are not just faint, they are a different species of existence. As we move into the late 2020s, the data from the James Webb Space Telescope and the Square Kilometre Array is pushing us toward a total collapse of known physics. We are finding that these dark galaxies aren't just invisible, they are weird. They are forcing us to reconsider what dark matter actually is. If dark matter were a simple particle, a WIMP, or weakly interacting massive particle, it should clump together in a very specific way, creating a dense cusp at the center of galaxies. But dark galaxies like the noob don't have this cusp. They are flat. Their mass is spread out in a way that standard physics cannot explain. This has led to the rise of fuzzy dark matter. In this model, dark matter isn't a heavy particle. It's an incredibly light particle, so light that its quantum wavelength is the size of an entire galaxy. Imagine a galaxy that isn't a collection of points, but a single, massive quantum wave. In this fuzzy universe, dark galaxies are not just clumps of matter. They are interference patterns in the cosmic fabric. They don't form stars because the quantum pressure of the dark matter prevents the gas from collapsing. We are no longer talking about astronomy. We are talking about quantum mechanics operating on a scale of 50,000 light-years. And then there is the most haunting possibility of all: dark stars. In the earliest days of the universe, before the first normal stars ignited through nuclear fusion, there may have been another kind of sun. These would be massive clouds of hydrogen and helium powered not by fusion, but by dark matter annihilation. As dark matter particles collided at the center of these clouds, they would release a steady, cool heat. These dark stars would be enormous, large enough to fill our entire solar system, but they would emit no visible light. They would glow only in the infrared. They would be the parents of the dark galaxies, a generation of invisible suns that lived and died before the universe ever saw its first dawn. The discovery of CDG-2 in 2026 provided the most chilling evidence yet. CDG-2 is a dark galaxy that was found not by its gas, and certainly not by its stars, but by its footprints. Astronomers noticed a group of globular clusters, tight balls of ancient stars, moving through the void in a perfect, synchronized orbit. They were orbiting nothing. There was no galaxy at the center of their rotation. They were the invisible moons of a phantom king. CDG-2 is a galaxy composed of more than 99.9% dark matter, a structure so dominant that it has captured and enslaved clusters of stars from other galaxies, dragging them through the void like trophies. It is a reminder that even if we cannot see the dark, we can see the wreckage it leaves behind. This brings us to a local threat: Smith's Cloud. It is a massive, starless cloud of gas, 11,000 light-years long and 2,500 light-years wide. It contains enough hydrogen to form 1,000,000 suns, and it is currently screaming toward the Milky Way at 700,000 miles per hour. It is on a direct collision course with our galactic disk. In roughly 27 million years, Smith's Cloud will slam into the Perseus arm of our galaxy. It won't be a quiet event. The impact will trigger a spectacular burst of star formation, a galactic baby boom that will light up the night sky of whatever creatures are left on Earth. But Smith's Cloud is a warning. It is a piece of the invisible universe that has finally decided to make itself known. It is a reminder that the void is not empty. It is full of mass, full of energy, and full of momentum. When we look out at the night sky, we feel a sense of peace because of the permanence of the stars. We see the constellations, and we feel that we understand the architecture of our home. But the dark galaxies tell us that the stars are an anomaly. We are the 1%. We are the rare, luminous exceptions in a universe that prefers to remain in the dark. The grandest structures in the cosmos, the true masters of space-time, are the ones that never felt the need to glow. They are the silent behemoths drifting in the abyss, the quantum waves the size of solar systems, the dark stars that burned without fire. The luminous universe is merely the foam on top of a deep, dark, and restless ocean. We have spent centuries studying the foam, marveling at its complexity and its beauty. But the tide is coming in. As our telescopes grow more sensitive, as we learn to hear the 21-centimeter hum of the neutral hydrogen and the gravitational groans of the dark halos, the ocean is becoming visible. We are realizing that we are not the protagonists of the cosmic story. We are the flicker of a match in a cathedral at midnight. The cathedral is vast, it is ancient, and it is filled with things we are only just beginning to name. We used to fear the dark because we thought it was empty. Now we fear the dark because we know it is full. The discovery of dark galaxies like Dragonfly 44 and the Newbie has fundamentally shifted our place in the cosmos. We are no longer looking at a universe of light with a few dark spots. We are looking at a universe of darkness with a few spots of light. And as we continue to map these phantoms, as we track the collision course of Smith's cloud and the synchronized dance of CDG2's invisible moons, we must confront the most unsettling truth of all. The ghosts aren't just out there in the distant clusters. They are here. They are surrounding us. They are the silent architects of everything we see and everything we are. The universe is not what it appears to be. It is a graveyard of stars that never were, and a cradle for a physics we are not yet brave enough to understand. In the end, the light doesn't reveal the universe. It only hides the darkness, and the darkness is where the real story begins. As we peer deeper into the radio spectrum, the missing satellite problem is slowly dissolving, but it is being replaced by something far more complex. We are finding that the darkness isn't just a lack of light, it's a spectrum of its own. There are nearly dark galaxies, optically dark galaxies obscured by dust, and true dark galaxies that are purely baryonic gas and dark matter. Each one is a different chapter in the history of the universe's failure to ignite. We are beginning to see the universe not as a collection of successful stars, but as a series of experiments. Some experiments resulted in the Milky Way. Others resulted in Virgo 21. The question that remains is what happens when these dark worlds interact with ours. When a dark galaxy passes through a luminous one, it doesn't cause a collision of stars. Stars are too far apart for that. Instead, it causes a collision of gravity. It ripples the disk, it bends the spiral arms, and it leaves behind a ringing in the galactic structure that can last for billions of years. Astronomers have found these rings in the Milky Way, mysterious ripples in the outer disk that have no visible cause. For years, they were a mystery. Now, we suspect they are the fingerprints of a ghost. A dark galaxy passed through us millions of years ago, and we are still vibrating from the impact. We are living in a haunted house of cosmic proportions. The walls are moving, the floorboards are creaking, and we are finally realizing that we are not alone in the room. The dark galaxies are the silent majority. They are the cold, rotating heart of the cosmos. And as we move forward into this new era of astronomy, we must learn to stop being afraid of what we can't see and start wondering why it chose to stay hidden for so long. The light is fading, but for the first time, we are finally starting to see.